Hello everyone, this is video number 2 for module 2. In this video we'll go through reading a file, then processing the attributes and looking into some missing values. So let's start with importing the data set, right? So still going to work with CSV file. A file name West Roxbury M2 is already provided through Messenger system, so please download that. So I'm going to create a data frame, naming it housing underscore data frame pd.read CSV, and we're going to pass the file name .csv and set the index. So index column equals to 0. Remember, the first column is transaction number, so that's kind of we want to use as the index column. So from here we can display data frame information, so which is housing underscore df, and as we run this we have data frame information like 5 head rows, 5 tail rows being displayed, right? We have some values here which are decimal points, for example floating point numbers, so this is called floating point, and these are the integer values, full bath, half bath, kitchen, when you actually look into the data set. And remodel is a kind of a string value. So if you remember in the data set we had none, recent, and old, 3 kind of different categories for the remodeling. So some of the things you can do here as part of data pre-processing or profiling, where I want to look into very high level information, such as I want to only display the attribute names, so the column names, right, or attribute names. So let's say so housing data frame attribute names are, so we just print a statement. So I just want to make it a bit more nice looking, right? Because you need to add the required information to tell whoever's reading your report what it is. So we can use dot columns. So housing underscore data frame dot columns. So let's execute this. So why I did this, as you remember in this particular data set, we have some white spaces. You will not notice these white spaces from here, right, as you're simply displaying the housing data frame. But as you display the columns or the attribute names, you will notice that there are some white spaces, which will create a problem as we want to process these attributes later on, right? So for that, what we can do is, very first thing, we can use renaming columns. So let's rename columns to strip out white spaces, right? Okay, so I'm going to put this as markdown. We already did the renaming in one of the previous lectures, so we can do is housing underscore data frame dot columns equals to s. S is a variable to kind of track the column names, strip, which will strip out the white spaces in front of the column name and at the end of the column name. And then we want to replace the intermediate spaces. So space, for example, this space here, total space value, with a underscore, right? And then we use a for loop. So for s in housing underscore data frame dot columns. So let's print the column names again. So print housing data frame column names, placing white spaces, right? So housing underscore data frame columns, right? So as we can see now, the white spaces are stripped out. We removed the any leading and then trailing white space, as well as we have used underscore to get rid of the space between 2 strings, right? So again, this is just to make your analysis a bit easier, right? Okay, so the other thing from here, you can look into data types. So I will explain data types in bit more details during our lecture. And so you can have different data types such as integer values, which are whole numbers. Then you have floating point numbers, which are decimal places. String values, such as these are the strings, total value. This is a string, none recent, right? You can have a Boolean type, which is true, false, or binary value, right? Okay, so in this case, I want to determine what is the data type for each of these attributes, different column types. What is their data type? Okay, so we already have the housing data frame, housing underscore df, and we can use d types. So as you can see, all these are the floating point numbers, float 64, which means the decimal values, right? So if you scroll up, all these are decimal values here, right? And remodel is the object. It's a string type, right? Okay, so string type is, so I'll come to in a bit more details later. But what we want to do in this particular case, we want to know what are the different string values, right? So we can convert this remodel into a category. So it will be really helpful later on when we do the clustering classification. So let's convert this remodel into a category. So if we go down, so I'm going to call convert remodel to a category. So I'm just going to make it a markdown. And so to convert into a category, what we can do is can use housing underscore data frame dot the column name, which is remodel, equals housing underscore data frame dot remodel. So as type will let you set a data type for a given attribute. So in this case, I want to set it to category. We've done that, so that's good. Then what we want to do is we want to display the categories. So number of categories in housing data frame based on remodel, right? And we can do it here is housing underscore data frame dot remodel dot categories. So as we run this, okay, so print, oh, sorry, again, use capital P, small p here. So as you print the categories, what you can notice here in this particular index here, there's a category name N, none, O, all, recent, none. So I intentionally created some mistakes in this data set. So I replaced some of the none with small n, capital N representing none as well, capital O representing old, right? So you can have these type of errors in a data set where data is collected from multiple sources, or perhaps it's simply a data entry error when somebody used a different category representation than what it was supposed to be. But usually these kind of mistakes can be rectified if you provide a drop down, right, to enter categorical values, right? But anyways, I just intentionally created this so that we can do some analysis here, sorry, pre-processing here. So that's that. Then okay, so we end up replacing the names, that's fine. Okay, so the other thing let's do from here, let's generate a quick descriptive statistics. Let me show you one more thing. So generate, so step number 3, generate descriptive stat. So let's do it as a markdown. So if you guys remember, we generated descriptive stats in last class. So housing underscore data frame dot describe. So as we describe this data set, let me just round it to 2 decimal places so that it looks pretty a little bit neater, right? Here we go. So total value If you look at the average total value is 392, minimum is minus 447, again a data entry error. House value cannot be a negative number. 1217, quite far from the average mean value. So we want to look into this particular entry to make sure this is not an outlier, right, or due to the data entry errors. I have done this intentionally. Again, this is the outlier. You will notice as you do further analysis that this value is pretty far from all other values, right? Similarly, if you look at the tax information, 15,319, pretty high tax value, right? And the other thing you may notice here is full bath and bathrooms, right? And kitchen, fireplace, 4 fireplaces, right? Okay, so you may want to kind of investigate based on these max values where this is happening and if this is a true instance or not, right? So the point I'm trying to make here is by looking at descriptive stats, particularly on maximum values, and looking into mean, you may want to draw some conclusions from here. The other interesting field is count. So I'm not sure if you guys notice, if I scroll up, when we display this information, describe, we had total 5,802 rows. Let's come down here. What we have in this particular descriptive stats, 5799. So which means there's some empty rows. There's some transactions where the total value is missing. Again, less than what our data frame size is, right? As you scroll to right, so there's some values missing for each of these attributes. So we want to deal with those missing values. Now, some of you may say, hang on, I don't see remodel, descriptive stats for remodel, because remodel is a category type, is a kind of a string value to start with. So what you can do is you can pass and describe another parameter. It's called include all. So once you do include all, it's going to include everything from the data frame. So we have 6 categories. We have 5798 row count, so which means there's some missing values. This 4338, let me just highlight this. This is frequency. This is the frequency or the number of occurrences for a category which is kind of coming maximum number of times within this data frame. We don't know which one it is, but we can create those frequencies in a minute. But this 4338 represents the maximum number of occurrences for a particular category in the data frame, right? Otherwise, you will see under total value, unique, top, frequency are NaN. These are not applicable because these are the number values. For number values, we want to look into mean, standard deviation, min, max values, and so on. So there's other type of stats, other things that you may want to look into. For example, let's say I want to look into the median value. Housing data frame dot median. So anyway, we have one non-numeric value. That's why we're getting this warning, right? So however, these are the median values, right? So the point I'm trying to make here is the things we discussed in the previous lecture. So you still can apply variance, median individually as well, right? Or max min as you require to process the information within a data frame, right? Let's just rectify this here. So you can kind of, well, let me just put it here. Numeric only equals to true, right? Okay, so that we have the arrow gone, right? Okay, great. So one more thing before we kind of move any further. So let's say I didn't display the data frame like we kind of looked into this data frame here for rows and columns, right? I still want to know how many rows and columns it has. So you can always display the shape, right? So housing data frame dot shape. I think we covered this in the previous lab too, right? So there are 802 rows and 14 columns, right? Okay. So from here, I'm going to kind of finish this video here. I will create a new video to describe how do we deal with the outliers and the missing values, right? So we'll see you in this video.